This happens whenever we first encircle Mercury. There at the front of our group of planets is Mercury, a small, uninhabited planet surrounded by a trap of intrigue and mystery. At first glance, nothing seems essential to this planet. However, NASA's ongoing research has revealed some surprising revelations about Mercury that no one expected. Some amazing revelations, including data from the James Webb Telescope, have sparked debate in the scientific community. Many point to the possibility that alien species are hiding in the world. Amid stormy discoveries and unusual speculations, a new plan emerges in the scientific community. This is a great strategy for removing Mercury's magnificent covers and revealing its dark secrets one last time. What amazing secrets have scientists discovered about Mercury, and what advanced plans does the scientific community have for this amazing cosmic neighbor? Join us in this video as the Webb telescope finally uncovers what NASA has been hiding from Mercury all along. Our local group of planets is more than just a collection of planets oscillating in the mirror of infinity. All 8 planets that make up this amazing ring system are surrounded by fascinating features. Despite the fact that planets like Jupiter and Mars are in the spotlight due to their amazing importance, another fascinating planet that seems to be missing from the group is Mercury. Mercury is the planet that comes first in the list of planets arranged according to their proximity to the Sun. Its distance from the Sun is only 58 million kilometers compared to the 150 million kilometers from the Earth. Mercury is also very small. Its diameter is only 3,000 kilometers. In its small radius around the Sun, Mercury is the fastest planet, spinning at an incredible speed of 47 kilometers per second. The planet rotates perfectly in just 59 days. In total, 1 year on Mercury is only 88 days, or 4 Earth months. Mercury's small size and tremendous speed are just some of its interesting highlights. From a distance, it even looks like a habitable planet on the cosmic map. The small planet has forever fascinated established scientists, but for reasons unknown, it has not received the attention that most of its cosmic neighbors have. The most important recorded sighting of Mercury was in 265 BC. Early stargazers like Zupus in 392 focused on the world. In any case, all the academic community had in those early days were scraps of information, because their research was done with the unsatisfactory scientific equipment of ancient telescopes. It was only after the 1960s that truly unerring information about Mercury became visible thanks to the efforts of NASA. A few years ago, NASA released the first real images of Mercury to the public. These stunning photographs showed Mercury as a divine example of magnificence and complexity. However, it did not work effectively. In fact, despite long-term planning and development efforts to explore Mercury, scientists have only been able to look at it directly. Scientists struggle with Mercury, like other planets, because it is close to the Sun. The Sun's unforgiving rays and bright light can damage optical instruments such as telescopes if they stare at Mercury for too long. As such, scientists can only observe the tiny planet for a few minutes to avoid damaging the equipment. Even the James Webb Telescope cannot photograph the planet due to its proximity to the Sun. It is very confusing how this small nearby planet is more difficult to study than the more distant planets due to the temperature and gravity of the Sun. Sending a probe to Mercury is more like a suicide mission than a celestial mission. The sensor must adapt to the temperature, environment, and gravity experienced there. If not, it will fail. It may shock you to realize that Mercury orbits the Sun at an incredible speed of 30 kilometers per second. This time-breaking speed makes it the fastest orbiting planet in our solar system. Your confirmation that this speed is also difficult for shuttles aiming to explore or land on the planet. So far, Mercury has been the target of only 2 space missions. Mariner 10 launched on November 3, 1973, and Messenger on August 3, 2004. Both missions were the brainchild of NASA and are the main source of almost all information about Mercury today. The Mariner 10 spacecraft made 3 flybys, each revealing Mercury's peak-like cratered surface and illuminating its magnetic field. In case you were wondering, this spacecraft was equipped with 2 telescopes, a spectrometer, a magnetometer, a spectrometer, and a plasma analyzer. NASA intended to gather as much information as possible about Mariner 10's visit to Mercury. As it turned out, the probe slowly tracked its way to a small, fast-moving planet. As Mariner 10 approached Mercury, scientists were amazed to see Mercury's turbulent surface inscribed with depressions and ridges similar to our moon. Mariner's images were amazing because Mercury turned out to be nothing like experts had ever expected. In addition to the planet's rough surface, the spacecraft also detected a weak magnetic field and an abnormally large core. In total, Mariner took more than 2,700 images of Mercury, giving scientists an unprecedented view of the intriguing landscape. Mariner's second flyby took place on September 21, 1974, capturing the southern polar region of the electric planet. Mariner 10 last flew by in March 1975, after which it stopped transmitting signals to Earth. Later investigations revealed that the spacecraft ran out of gas and was unable to complete additional orbits. Mariner 10's great work continued 30 years later when NASA's Messenger left for a nearby planet. Like its predecessor, Messenger not only flew by, but could also orbit the planet. Thanks to this, scientists were able to collect more extensive and interesting information about the planet. Armed with exciting images of Mercury, NASA sought deeper insights with this mission. This time it wasn't just about the pictures. The agency needed information about the atmospheric conditions and chemical composition of the planet. NASA also had to study the planet's magnetic field and delve into its geological history and the planet's core. As expected, the nuclear probe was equipped with all the tools necessary for this important mission. Interestingly, the probe made 3 orbits around Mercury, during which it took about 200,000 photos of the planet. These photos were extraordinary because, unlike the Mariner mission, they covered both sides of the planet. During the nuclear mission, the probe managed to get very close and hovers about 250 kilometers above the surface of the planet. This proximity allowed the probe to photograph both the bright and dark sides of Mercury. Later, digging deeper into the images and comparing them with data from the spacecraft's instruments, NASA discovered that our dear sister planet has unusually high concentrations of calcium and magnesium at night. In addition, the planet's magnetic field appeared unusually twisted, appearing increasingly stronger in the northern regions. This strange magnetic field pattern puzzled scientists for years until a comprehensive study was conducted to uncover the mystery behind this anomaly. Mercury's strange magnetic field is the result of how the planet formed in its core. The magnetic fields of the planets are created as a result of reactions in their cores. For example, the Earth's inner core contains liquid iron.
Near the inner layer, this iron solidifies. Continuous or moderate hardening of liquid iron creates a magnetic field. Then, strong electric currents are generated, creating a large magnetic field that reaches into space. This is exactly how the lines of force of the Earth's magnetic field are created. However, it is a different scenario for Mercury. Mercury's method of generating a magnetic field is so strange that it has baffled scientists. A recent study led by W of the University of California, Los Angeles found that iron goes from liquid to solid at the outer boundary of the core. This is quite different from Earth, where the transition from liquid to solid occurs at the inner boundary of the core. W commented, "We figured out how Earth works, and Mercury is another rocky planet like Earth that has a core, so we thought it would work the same way. But no. It's like a blizzard with snow, cloud, center, and base. Our analysis of Mercury's magnetic field shows that iron reigns throughout this fluid, which drives Mercury's magnetic field." Further research showed that W's studies were consistent with data from NASA's Messenger mission. The surprising revelation led scientists to believe that planets have more than one way of creating a magnetic field. Although the cores of Mercury and Earth contain similar components, such as sulfur and iron, the specific differences between the two planets can create remarkably different ones. This challenges conventional models and forces scientists to refine their understanding of how planets develop unique properties based on their individual histories and environments. In addition, research on the composition of the surface of Mercury gave surprising results. Unlike its more distant and larger neighbors, Mercury's surface lacks significant amounts of iron oxide, giving it a darker appearance compared to the rusty red surfaces of Mars or even the Moon. This scarcity of iron oxide suggests that Mercury formed under different conditions than other terrestrial planets, perhaps as a result of intense heat or chemical processes that changed the composition of its surface. Recent studies using data from the MESSENGER mission have also detected volatile elements, such as sulfur and potassium, on the surface of Mercury. These findings challenge previous assumptions about the geological history of the planet and provide new insights into its formation and early evolution. The presence of these volatile elements indicates that the surface of Mercury has undergone complex chemical interactions and changes over billions of years. In addition to its geological and magnetic mysteries, Mercury also presents exciting challenges for future study and understanding.